I'm going to give you all of the chemistry information that you should need to be successful in AP Biology. You did take a course called Chemistry. All of this information should have been included in that course. However, I know some people need a lot more practice than others. I am going to go through, first of all, this chart right here. This is very basic stuff that you will need for anything else that I talk about in this video and later in the course. Just subatomic particles, the charge, the mass, the location, and what happens if the number of that subatomic particle changes. I'm also going to give you some information about the periodic table, namely atomic structure and valence electrons, electronegativity, bonding, that sort of thing. We'll cover those concepts, and then we'll cover 3 more concepts that are pretty distinct from one another. How shape leads to function in molecules in life, dynamic equilibrium, whatever the heck that is, and using radioactive tracers in living things. All right, so back to the beginning. I'll be going through this. I'll be filling this chart out. This video cannot be passive. What I mean by that is you need, if you don't know this stuff, you need to be thinking as you go. So you can't just turn this on and listen to it while you're just kind of doing something else, washing the dishes, whatever. You need to make sure that any information that is a strong refresher or brand new to you, you are thinking about everything that I'm doing, which means press that pause button. The space bar works on YouTube to pause the video, think about what I'm saying, process the information, rewind it if you have to. I'll try to pause a little bit after I ask little questions. Pause the video. Think about it. Maybe draw this chart out. See if you can fill it in. Go ahead right now. Pause the video and draw the chart. See what you can do. And then press play and see what I do. All right. So here we go. Protons. An atom inside the nucleus is made of protons, neutrons, and electrons. The proton has a positive charge. Mass. We say that it has a mass of 1. 1 what? 1 Dalton. It's just a unit. It has a mass of 1. Don't worry about the units. It has mass. Location. We would say that the protons are located in the nucleus. I'll come back to this column once I've filled out these ones. All right, so if you've made mistakes on yours, maybe now you're able to correct them. So pause the video, correct your mistakes, come back and see what's going on. All right, so neutrons. Neutrons are neutral. They have no charge. They do have a mass, and they are also located in the nucleus. Electrons have a negative charge. They have what we say is negligible mass, basically no mass. And they are located in the electron cloud. Or outside of the nucleus. All right, now we ask the question, what if the number of each of these changes? So if I change the number of protons, well, elements are actually named by how many protons they have. So carbon is carbon if any atom is carbon if it has 6 protons. If you find an atom and it has 27 protons, that is cobalt. That is what it is. 1 proton, if you find an atom somewhere that has 1 proton, that is hydrogen. So if you were to change the number of protons, well, you do some things here, of course. You know, if you add 1, change the mass, of course, you add another, okay. But what we really say is the element changes. Changes the element. So it changes the element. Okay. Neutrons. That is going to lead to a special kind of atom called an isotope. But it's not good enough just to say that. Say isotope. We've got to say what does that do? Well, it's not going to change the charge any, but it is going to change the mass of whatever element we're talking about. So if we have carbon, which typically you'll find has 6 neutrons, if you add a neutron, suddenly that carbon is heavier. We would call that, if the normal isotope of carbon, we say that's carbon 12, because it has 6 protons, each weighing 1, and 6 neutrons, each weighing 1, for a grand total mass of 12. That's the most common isotope of carbon. But if you add 1, well, we call that carbon 13, because it's heavier. It's a heavier atom. It's an isotope. Okay. And electrons. If you change the number of electrons, you get something we call an ion. And it's not going to change the mass, but it will change the charge. So if we have, let's go with carbon again, even though this is maybe a silly example, but if carbon, with normally it's 6 protons, in order to be neutral, it would need 6 electrons. That would make it a neutral atom overall, because we'd have 6 of these and 6 of these, so they cancel each other out. But if you were to give carbon an electron, I want you to think about this. Maybe pause the video. If you were to give carbon an extra electron, so now it has 6 protons and 7 electrons, what's going to be the charge on it? The charge would be a -1. We gave it an extra electron. We gave it an extra negative charge. All right. So now that we have this information, maybe you've copied it down so you can reference it. Now we can move to talking about some stuff on the periodic table. Let's start with atomic structure.